In this problem, we want to draw a chair conformation that meets specific criteria. So the first is an axial CH3 at carbon 2, and you were given a chair template, and on carbon 2 we have an axial substituent that points straight up because that's an up carbon, an equatorial substituent that points straight down. The equatorial must just be a hydrogen, which you don't have to draw in. You could just leave that bond off there completely. So in fact, I'll just erase it. And then the axial is going to be a CH3 group. Okay, the next thing is to put in an OH with an R configuration at carbon 1. And this one can be a little bit tricky. So let's go ahead and just draw in our substituents like this, and the OH will go in at one of those positions. But how do we know which one? Well, on the chair, it can be a little bit difficult to decipher. So what I recommend doing here is actually drawing this in a more two-dimensional form with dashes and wedges. So at carbon 2, I'm going to put in the CH3 group. Since it's pointing up, we'll put it on a wedge. And then carbon 1 is where the OH will go. And my recommendation for this is just to do it by trial and error, meaning put the OH out and see if it's the right configuration. If it's not, switch it. So let's put the OH on a wedge and see what the configuration is. So if the OH is on a wedge, we have a hydrogen back. Let's prioritize these groups. So the OH is 1. Then we have this carbon of the ring would be 2. This carbon of the ring is 3. And the hydrogen is 4. So now we have the H, priority 4 group back, which is how we want it. Draw in your curved arrows. 1 to 2 to 3, that's going around to the right. That is the R configuration. So we do want the OH on the wedge. If we had done this and let's say you started and put the OH back, you would have ended up with the S configuration. To get it correct, then you just switch it from back to front. So now we can come back up to our chair. And we know that an out group is up on the chair. So coming to carbon 1, I can put the OH as my upward pointing group. A hydrogen is the axial downward pointing group. Again, I'm going to leave that hydrogen implied, so let's just erase it. Okay, the last thing I need is a Br at carbon 4 that is trans to the OH. So if we come over to carbon 4, we have an axial and an equatorial group. Now what you want to kind of think about here is the carbon of the ring being a plane. And let's look at 1 and 4. On carbon 1, the OH is above the plane. And then at carbon 4, if we want a Br that's trans, that means we want one above and one below the plane of the ring. So since the OH is already locked into the position above the plane, I'll put the Br in the position below the plane. So now we have the OH going upward, the Br going downward, and that is a trans relationship. And then my axial substituent is a hydrogen, but again, I'm just going to erase it and leave it implied.